name is Karuna Singh. Welcome to the channel North Star Continuous Knowledge Excellence. In this video, we will get to know about the morphology of MOF and detection selectivity towards lead and cadmium. Now, our expert, Professor Himadri B, Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Delhi Daikin Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobiointerface science, soft matter science, polymer physics, biophysics. Will explain you in detail about this topic. So, to get complete information, watch full video without skip.
This is again the morphology as seen through the TAM experiments. This is the bare. Then after ion exchange with lead, ion exchange with cadmium, ion exchange with cadmium and lead together. From here, you can hardly see make any distinction. It's not possible to say whether the material has lead or material has cadmium from here. You can do a particle size analysis and other things, physical analysis, etc. can be done. From the data itself, from the visible, the information that you get from the photograph of the TAM, it's not possible to make any conclusion from here. So one needs to go a little deeper into the electrochemistry of this. This is the EDEX analysis. When you do the ion exchange, then ion exchange with the lead, you see that the lead has now appeared here. When you do with cadmium, the appearance of cadmium is there. Copper or carbon, oxygen were there in the electrode itself in the beginning. After ion exchange, you start seeing lead and cadmium there. And when you do for both, lead and cadmium both appear there. So this is from the electron microscopy data. Now the same thing has to be captured in the electrochemistry from our electrochemical cell experiment. Okay, now this is the current voltage response. I'm not showing the entire voltagram, but this is only the peaks that are being shown here. This is the current that's arising because of the presence of the cadmium. And this is the copper signal. Initially, the bare electrode had a very strong current represented by this, mostly contributed by copper ions here. Once it is ion exchange with cadmium, peak of this has gone down, peak height has gone down, and this is shown now as a prominent peak here. Same story with lead. Bare electrode, MOF only. You can see this is only the bare electrode. And after exposure to Pb2, the additional peak will appear here, and this peak height will drop to this value. Now, the same experiment in presence of many other interfering metal ions, cations, like nickel, cobalt, zinc, magnesium, mercury, etc. Okay. Now, you see different current values that is coming here. There is one place that copper peak is there. Copper peak is constant here, but different heights for different elements here, cations here. But there are different responses that are coming from different cations. There are individual contributions like cadmium, lead, zinc, etc.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
And others are not contributing. We have something like 1, 2, 3, 4, 5, 6, 7, 8, 2, 6, 7 elements here, cations here, but the peaks are there for only 3. So it is detecting only 3, or other 4 have no specificity. Now, if you take the current values and try to turn it into a bar plot, then this is what you see. That you see distinct current for lead, cadmium, and zinc. For nickel, cobalt, manganese, copper, etc., that the signal is extremely low. Mercury signal is quite low. Detection efficiency is very, very low. It's predominantly detecting lead, cadmium, and zinc. So this is now a detector for your heavy metal ions. The electrode is sensitive to these 3 heavy metals. Now, after that, you can make all those linearity plots and other things like I have discussed earlier. So we have the peak corresponding to the pollutant heavy metal that is increasing. As the concentration increases, the copper signal decreases. So you can take the value of the absolute value of this and make a calibration plot like this has been made here. Or you can take a ratio between the two peaks, current value of for lead, which is this one, divided by the copper value, current value of the copper, which is this one. So IPV by ICU. Then you get a plot which is like this, but at the lower concentration limit, if I just confine yourself to very low concentration, 0 to 6 micromolar concentration, which will turn out to be some ppm level detection, it shows a beautiful linear plot with a nice correlation coefficient. For lead, the story is more or less same for cadmium. Same analysis, your cadmium concentration up, current value is increasing. Copper, current value corresponding to copper ion, that is decreasing. This is the bare electrode response, it is decreasing. So either you take the absolute current and then you plot it as a function of the analyte, which is a cadmium, you'll get a plot like this, or you take the ratiometric analysis method, current of due to cadmium ion divided by current due to the copper ion, this divided by this value. Then you have this nonlinear plot, but just look at the low concentration region, 0 to 6 micromolar, which is again the ppm value, much of the order of ppms. Then you will see a beautiful linear curve here. So this basically means that the electrochemical cell, when you make this electrode, it is sensitive to the heavy metals, lead and cadmium. So this is a way of detecting lead and cadmium. And when both are present, then very interestingly, you will see that the peak for lead, there is a peak for cadmium, there is a peak for copper. Okay, so you can again make the same ratio, current ratio between lead and copper, current ratio between cadmium and copper. Low concentration region, see nice linearity here, nice linearity there. So whether they are present in solo in water, or they are present in a combination, they can still be detected very efficiently through the electrochemical cell. That is the whole idea.
I hope you liked the video. Here I would like to give you an important information that Nanoscience and Technology Consortium, or NSTC, organize the nanotechnology workshops on amazing topics. Also, I would like to tell you about the initiatives of NSTC in which you can also be a part of. Mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. One more thing, and that is, if you want the full recording of the previous videos, so you can contact us on info@nstc.in. Further, if you want to enroll in the upcoming workshops, then you can go to the website www.nanoschool.in. And yes, subscribe to the channel Knowledge Star and hit the bell icon to never ever miss an update. Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.